Well, so far we have covered a few gate electrical papers, three gate electrical papers. So now in this video series, we are going to start with the review of the next paper, 2015 Set 2 for the electrical branch. Well, here is the first question. Given f of z equals g of z plus h of z, where f, g, and h are complex valued functions of a complex variable z, which one of the following statements is true? Okay, so for this question, let's analyze each of the options. We'll start with option A. Now, option A says if f of z is differentiable at z0, then g of z and h of z are also differentiable at z0. Well, this is not really true, because if f of z is differentiable, it's not really necessary for g of z and h of z to also be differentiable at the same point z0. Now we'll take an example and show why it doesn't really have to be true. Okay, so we have our given expression which says f of z equals g of z plus h of z. Now each one of these three are functions. Now if f of z is differentiable, the option says that g of z and h of z are also differentiable, but it's not true. There can be instances where g of z and h of z, two different individual functions, need not be differentiable at the same point. So we'll take an example. Let g of z be say 4x plus I phi y, and h of z be 5x plus I 4y. So what would f of z be now? F of z is the sum of the two. So it's 4x plus I phi y plus 5x plus I 4y. Now if we add them, we get 9x plus I 9y. We can write this as 9 times x plus iy, or 9z, where z is x plus iy. Okay? So here we will notice that the Cauchy-Riemann equations are not satisfied. In order for a function to be differentiable at a certain point, they must also satisfy Cauchy-Riemann equations. Now recall what the basic Cauchy-Riemann equations are. Cauchy-Riemann equations are, we have two of them. Dou u by dou x equals dou v by dou y. This is the first. The second is dou u by dou y equals minus dou v by dou x. This is the second. Now we see here that these two equations, when we try and find out if g of z and h of z satisfy Cauchy-Riemann equations, we find that it is not true. They don't satisfy Cauchy-Riemann equations. So in this case, f of z is differentiable, but g of z and h of z need not be differentiable at the point z0. So this means our first option is wrong. It's not true. Now let's look at the second option. The second option says if g of z and h of z are differentiable at z0, then f of z is also differentiable at z0. This is a sort of a opposite of the statement A. Here B is actually true, because if G of Z and H of Z, two individual functions, complex functions, if they are differentiable at a certain point, then the sum of the two differentiable functions is always differentiable. That is important here. I'll note this down here. This is an important point. The sum of two differentiable functions is always differentiable. So B is the right answer. But let's analyze C and D as well. If f of z is continuous at z0, then it is differentiable at z0. Now here the opposite is true, but if f of z is continuous, then there is no, it's not necessary for it to be differentiable as well. If it is continuous, not necessarily differentiable. So C also rules out. The same goes for option D as well. If f of z is differentiable at z0, then so are its real and imaginary parts. If the real and imaginary parts are differentiable, then f of z is considered differentiable. But if it is said that f of z is differentiable, then it need not mean that the real and imaginary parts are also differentiable. So D also rules out. So the right answer here is B, where the sum of two differentiable functions, g of z and h of z, is always differentiable. Therefore, f of z is differentiable. Well, B is the right answer, and I hope this explanation has helped.